Welcome to the Fundamentals of Engineering, and today's topic will be the engineering design cycle. What I'll be covering today you can find in chapter 12 of your book, and I would suggest that you actually read the book on chapter 12. I think it goes through a lot of great information on the design cycle. I'm going to briefly kind of go over it as an overview from the book itself, kind of give you the basic steps of the process, and then I'll make another video following this one, which will kind of give you one example too. So if we think about if you're designing a product, how would you do it? What steps would you do without really knowing what the process is, right? So I like to use this example and think of making a paper airplane. If I asked each of you to make a paper airplane, you may ask me a few questions. Well, what do you want this paper airplane to do? Would you want it to do tricks? Do you want it to go really far? You know, what is the characteristics of it? So there's the first step, is really kind of defining what type of paper airplane you might want to make. From there, typically, if you're going to make a paper airplane, then you've got some ideas of what one might be. And if you're doing it as a competition, you may make up different ones. You might sketch some ideas if you're working with other people, or you might just start folding paper and make some, and then you kind of test them out. So you're kind of making ideas and generating concepts. You're prototyping and testing these things, right? Until you find the one that you think is maybe the best one in the class, right? So you kind of go through these steps of concept generation, kind of idealizing and imagining what it might be, selecting what you think is the best one, kind of testing it, and then you make your final one, and then you present it and do your test on it. And that's kind of a basic engineering design cycle. So you already kind of know, I think, how to do this, all right? So before we actually get into the full steps of it, I just want to talk about why we would use the engineering design cycle and what is it really. And it's really a systematic method to find a solution, right? To solve some type of problem or to fill some type of need. Okay, so with the paper airplane example I gave you, I kind of gave you a problem, right? I wanted you to design a paper airplane. You asked me what my need was. So kind of here it's kind of a both kind of a thing. And this process can be applied to design of equipment and products, structures and different processes. It can be used for a lot of different types of things. So what does it really do? What types of problems does it solve? It can solve problems for reducing cost of maybe producing the product through manufacturing or just the parts itself. Maybe you find ways of reducing cost of the parts, less material, that type of thing, or different materials. It can be used to reduce waste, which also would reduce the cost, right? And we wouldn't have so much waste in filling our landfills. Maybe we can find a way to reuse things, make it more sustainable. Increase productivity on the manufacturing side of things. We may use it there. Or improve the quality, right? Maybe our quality is coming back. The paper airplane that we made maybe wasn't the best one. It's not repeatable very well. Maybe we can go back and make a better one. And also we can use it for safety, improve safety, are some of the main things that we can kind of look at it. So where in society does the engineering design process solve problems? One thing that can be used, if you're a civil engineer, you can use it to design new buildings and structures as a civil engineer. You can use it to design new machines or equipment, maybe as a mechanical, even electrical engineers would do that. Manufacturing engineers would do that. Create new products that people want to buy and use, and all of the different disciplines really kind of fall into that. Maybe not civil so much, but a lot of the other ones will all fall into that kind of area. And then also improve existing products or to add some value to existing products. All right, let's look at the actual steps of the process itself. The first step is to define the problem, right? And this is the most important step. You must remember that this is the most important step, because if you define the problem incorrectly, then you will not come up with the correct solution. So you have to identify the problem, find the need, right? Keep asking the questions over and over to find the need of what the problem is and what really is required. Um, so one way of doing this is you can frame the problem as a problem statement, right? And you'll need to come up with a problem statement in the define phase. And that is from the customer's perspective. So your problem statement should answer the following questions. What is the problem or need? Or who has the problem or need? And why is it important to solve? So one format you could use is who needs what because why, right? So John needs a paper airplane because he wants to show tricks with it or whatever, right? Or he wants it for a competition, right? So you can write these problem statements. The problem statements need to be very carefully written. They do not give solutions. So it needs to be very open-ended, but kind of state what the need is and what you're trying to solve. So essentially, also in this phase, you can establish some criteria. So like with the paper airplane idea, it could be, distance. Maybe it has to go so many feet, or it has to do so many loops. That type of thing would be some of the criteria. Other things might be cost, right? In a real engineering project, you're always concerned about cost. Customers don't want to pay a lot. Size, weight, and strength, right? We might be building a new car. We may want a certain size, but we don't want it to weigh so much so we don't have bad miles per gallon, right? The strength for crashes and things like that. If we're going to sell this car, we want it to look good, so the aesthetics may be important to it. And it maybe need to be easy to drive and intuitive on how you would drive the car, right? So ease of use is another thing. And safety, of course, right? Always safety. We're always looking at safety. And maybe it's recyclable. Certain parts of the vehicle could be recyclable. You kind of want to look at the whole life cycle from where do the components come from, how long does it last, and then what do we do when it's at the end of life. So these are some of the specifications that you may want to look at. The next step is the imagine step, right? And in this step, there's kind of two parts to it. One is the internal research and look what's already been done, and the external research, and then your internal research. So external research is to look what's already been done out in the market, right? You can look at patents and maybe use some expired patents, or look at what your company has for patents on products. Explore what the current market really has. Take products apart. Do some what we call reverse engineering, and kind of look back and see how someone made some other product and how you might be able to make it better. A lot of companies do this. So that's part of the whole product dissection and taking the product apart. Internal research is to look at what you currently have within your own company. Maybe there's certain patents you have or certain products you're already selling, and maybe you want to improve on those, or maybe you can take some of that technology and branch out into a new product. Also in the imagine step is the concept generation. How do we generate these concepts and new ideas? There's many different ideas on here. I'm just going to list those out and we'll look at those. Most of you have done some type of brainstorming, and that's probably the most common one. But we'll have a whole lecture just on concept generation. So in this imagine area, we're kind of doing research first, external and internal, and then we kind of generate as many concepts as we can to solve our problem. After that, we go into the concept selection phase or step, and here we are going to analyze our potential solutions, right? We can use a decision table. The book talks about a decision table on being able to select the right concept that we want. We'll look at other ways of doing it through concept screening and concept scoring. We'll have a lecture on this also. These last two are not in the book, but I highly encourage you to use them. And then you'll want to develop some test models or prototypes, and they should match per the criteria and the goals as how we're going to test it. We can use different methods like rapid prototyping. Everybody's heard about 3D printing. That's one method of rapid prototyping, but you could do other types of prototyping. You could do it through computer modeling. computer simulation, CNC modeling, all sorts of different ways we can model up products. If we've evaluated that at that phase, and let's say we've been successful on it, we go into the next phase, which is create, which is our documentation phase. And here we will develop our final specs from our initial specs from the defined stage. We will design the actual product. Maybe we're using CAD, and we'll prototype it. And if you're going to design a product, you can take Engineering 110 and learn about CAD and how to do that. So this is all the documentation type information. The next phase is the test phase, and this is our final test before we actually start and manufacture it. Right? We're going to do some final testing on the final product before it goes out and before we really start building it. Then we'll build our product, purchase our equipment for it, document the product and procedures, and look at product packaging. That's a whole nother engineering area that could use the design process, and get it out there, right? So this whole process kind of continues on, and it has this improvement cycle. You'll see on here I have these dashed lines. These dashed lines really could go to any other section. This is really not a linear process. It is a process which kind of goes in any direction. So it can go anywhere, right? I can go from test, and let's say we tested it and it didn't work well. Well, maybe I go back here to redefine it. Or maybe I have to go back to my imagine phase and come up with new concepts. So while it shows it as a linear kind of thing going in this direction, I do have these other ones you see going back, right? I could evaluate and say, oh, this is bad. Maybe I need to go back and get new concepts. Or maybe I need to go all the way back and come up with a new definition, right? The problem. So it is not a linear process. It's a constant process that's kind of going around and around. All right. And in the end, we're also going to monitor the product for product quality and see how it does. And then we can also look at destructive testing and non-destructive testing of the final product. Okay. And we can use analytical methods, age acceleration type things. If you ever thought about how does one know that a product will last, a switch will last, or a light bulb will last 7 years or whatever, well, they can do it through age testing. They put it through high temperature, low temperatures, high humidity, low humidity, and actually can age the product very well and get some good estimates on it that way. And then we won't be talking about root cause analysis, but that's other tools we can use to improve our product each time. Okay. So the last thing we want to make sure we know is the product meeting the customer needs? That's probably the most important thing. Did we come up with the proper solution? Did we define the proper problem properly and come up with the correct solution at this phase? Did we generate the proper one, and did we select the correct one? And then is it really the one that was going to solve the problems? The book goes through all of this and does a very good job at it. I highly recommend that, again, that you read it and take some time understanding this process. We will be using this process for our design project. All right. If you have questions, always come and see me, and I'd be happy to answer any questions.